Now, in September of 1919, President Woodrow Wilson spoke to a crowd of nearly 50,000 at San Diego's Balboa Stadium in favor of his proposed League of Nations. In addition to the excitement surrounding a visit from the president, the Journal of San Diego History reported that those in attendance also witnessed a major triumph in technological history. It was the first time the president had used an electric device to capture his voice and, after amplification, make his voice heard to a large live audience. That device was a microphone. The microphone was invented years before Wilson's speech by German-born American inventor Emil Berliner in 1876. According to the journal Technology and Culture, Wilson's speech is just one illustration of how microphones were first used. Today, microphones have countless applications: telephones, hearing aids, radio, television, and motion picture productions. Over the years, the microphone has changed its shape and form. However, it has retained the same identity at its core. A microphone is a transducer which converts one form of energy into another. In the case of microphone, sound is converted into electrical signals. The application of Lenz's law, which was built on Faraday's law of induction, was applied to make this possible. Now, Lenz's law, named after physicist Emil Lenz, who formulated it in 1834, says that the direction of the electric current induced in a conductor by a changing magnetic field is such that the magnetic field created by the induced current opposes changes in the initial magnetic field. It is a qualitative law that specifies the direction of induced current, but states nothing about its magnitude. Lenz's law predicts the direction of many effects of electromagnetism, such as the direction of voltage induced in an inductor or wire loop by a changing current, or the drag force of eddy current exerted on moving objects in a magnetic field. Now, Lenz's law of electromagnetic induction states that when an electromotive force induces, according to Faraday's law, the direction of that induced electromotive force is such that it opposes the cause of its production. According to Lenz's law, E equals minus n bracket d phi over dt, where n is number of turns in the coil, phi is the magnetic flux, and t is the time. In this lesson, we have learnt about Lenz's law of electromagnetic induction and also the formula to calculate the same. In the next lesson, we'll be looking at some applications of electromagnetic induction.